Hello everyone. In this video we are going to see how to use a DigiLent development board such as the Arty S7 in this case for signal processing purposes. Here you can see the oscilloscope, which is connected at the output of the DAC, and a signal generator at the input. The internal ADC of this Spartan FPGAs, it's a pretty well documented topic both by AMD and the community. However, setting up these external modules, like in this case the DigiLent PMOD DA2, can be a little bit confusing. So this is why I am doing this video. So let's go through each stage of this implementation, and by the way, you can find in the description the code, the link to my GitHub repository. Okay, now I am the project manager. First of all, we're going to see how to configure the ADC. As you can see, this is a pretty standard configuration, single channel. Also, I'm using the highest achievable frequency, at least with this board, which is about 961 kSPS. And as I said, I'm using a single channel setup. The external DAC module has two channels, so we could use a dual channel setup. But in this video, for the demonstration, I will use just a single channel. Okay, let's jump to the code. Here you can see that the code is divided by interface, the ADC and the AC components, utilities, clock divider, flip-flops, and the processing main, where you can perform any DSP stuff. Regarding to the ADC controller, here you can see the controller, which is a simplified version of the ADC wizard component, and we're gonna use it in the top level file. Now let's jump to the most important part, which is how to initialize these SPI DACs. We are going to use drivers provided by DigiKey for this module. On the DigiKey website, you can also see a detailed explanation of how the modules work. This is the SPI controller, and this is the main DAC component. In this file, we only need to set the clock frequency of our system, which in my case is 100 megahertz, the same one I used to set up the ADC. So finally, this is the interface main, which I made to hook up every component. Here is the DAC, the ADC, simplified ADC, a clock divider, the processing main, and a flip-flop vector to make a input and output buffers. Here you can notice that the B channel of the external DAC is not used because, as I say, this is a single channel implementation. What else? Here you can see that I'm sending the most significant bits to the DACs because the DAC has a resolution of 12 bits. And if you have any questions about these implementations, just leave a comment. Now I'm sending 2 kilohertz signal, and we can see that the signal starts to get worse as we go up on frequency, because these DACs are not high speed. Worse and worse. Well, but for low frequency, for audio frequencies, we have a pretty good response for do low frequency DSP stuff. So thanks for watching, and if you have any questions, just leave a comment. Thanks.